In this video, we'll be going over our exterior angles of polygons. So an exterior angle is an angle that is formed by the line coming off of one side of a polygon and then the next side. So in this example, when we have our triangle where the interior angle is worth 30 degrees, we can draw an imaginary line coming off of that side of the triangle that would be a total of 180 degrees. If the interior was 30, that means that the exterior angle is 150. Similarly, here we have a 1, 2, 3, 4, 5-sided figure, which is a pentagon. It is not regular, but if we know the exterior angle here is 115 degrees, we can figure out that the interior angle here would be 65 degrees because it's creating a 180 degree line off of the side of the pentagon. So it's creating that line and it's going to add up to 180 as a total with that exterior angle. So our polygon exterior angles theorem says that the sum of the measures of the exterior angles of a convex polygon, where one angle is at each vertex, is 360 degrees. So for example, here in this triangle, we can see that if we extend a line off of each side of this 30, 60, 90 right triangle, then a line forming with 60 degrees would have a 120 degree angle, a 90 degree angle, and a 150 degree angle. And if we add all of these values together, 90 plus 120 would get us 210, plus another 150 would be 360. And this is going to work with every polygon, no matter what that interior angle sum is. As we're getting more and more sides, we get closer and closer to a circle, and the interior angles of a circle are always 360. So this is ultimately going to create, if you put all of these exterior angles together, a circle with all of those angles. So we have that exterior angle sum every single time we have a polygon as 360. So in this next example, we can see we don't have a triangle anymore, but we do have a quadrilateral. So even though this has a different interior angle sum than the triangle did, their exterior angles, based on the polygon exterior angles theorem, should be a total of 360. That means that if we take all four of these exterior angles, like 60, 120, 2x plus 10, and 4x minus 70, and we take their sum, then they should be equivalent to 360. When we go ahead and solve this, we'll take 60 plus 120 is 180, plus 2x plus 10 plus 4x minus 70. When we add our like terms there, we have 2x plus 4x, which is 6x, and 10 minus 70 is negative 60. We'll continue combining our like terms, and we're left with 120 plus 6x equals 360. To solve, we'll subtract 120 from each side, and we're left with 6x equals 240. And to get x alone, we'll divide by 6 on each side. That means that our x in this example is worth 40. So up here, this exterior angle would be 4 times 40 minus 70. 4 times 40 is 160. When we subtract 70, that would be a 90 degree angle. And then over here, we have 2x plus 10. So we will fill in our x value of 40. So 2 times 40 plus 10 would be 80 plus 10, which is also 90. So both of these exterior angles would be worth 90. Now, obviously this picture is not drawn to scale, but we're using our exterior angles theorem, where every exterior angle sum on any polygon will be 360. Over on this shape, we have 1, 2, 3, 4, 5 sides, so this is an irregular pentagon. Based on our polygon exterior angles theorem, that all of these sums of these exterior angles should be 360. And actually, sorry, I miscounted. That should be a hexagon here. We have 1, 2, 3, 4, 5, 6 sides. So there are actually 6 sides of this shape. So what we're going to do is take all of our angles, 100 plus 10 plus 90 plus 2x plus 3x plus 3x. We're taking their sum and setting them equal to 360. Once we do that, we can go ahead and solve for x. So 100 plus 10 plus 90 is 200. 2x, 3x plus 3x is going to get us 8x, and we are left with setting that equal to 360. Subtracting 200 gets us 8x equals 160. We'll divide by 8 on both sides, so x will equal 20. If x is 20, that means that this angle up here would be worth 40 degrees. This would be 60, and this one would also be 60. So we have a total here of a sum of 360 degrees for all of our exterior angles. So this will be the case for every single polygon, no matter how many sides there are, all of those exterior angles will always sum up to 360.